Ever get that feeling? Like you're drowning in info, all this stuff coming from AI models, right? But you just need the core insights, structured and validated, like somebody to wrangle the data for you.
Yeah, totally.
Today, we're going to dive into a tool that does exactly that. It's like having a personal AI data wrangler.
Nice.
So this deep dive, we're focusing on getting structured data from LLMs, large language models. They give you all this text, but it's not always in a format you can actually use easily.
Right, right.
We're going to be looking at a tutorial document that explains a Python library. It's called Pydantic, and specifically this thing called the agent class. Sounds kind of mysterious, right?
Yeah, a little bit.
But our mission today is to make this clear, even if you're just starting out with this stuff. We want to help you understand how Pydantic can help you get that nice, organized, validated data from those LLMs. No more getting lost in technical jargon.
Exactly. We're breaking it down.
Because LLMs are great at generating text, but sometimes you need something more specific, like JSON, or just a particular object format, and getting that can be, well, a bit of a pain.
Yeah, it can be a real struggle.
That's where Pydantic comes in. It solves that problem. So let's get into it. What exactly is Pydantic?
Okay, so at its core, Pydantic bridges this gap. You've got unstructured text coming from the LLM, and then you have these structured, validated Pydantic data models that Pydantic connects them.
Okay, interesting. So it's like a translator almost.
Yeah, kind of. Like, it translates the messy AI output into something you can actually use, but also it's like having a quality control expert making sure the data is, up to standard.
Oh, I see. So it's not just about converting the format. It's also about validating the information, making sure it's accurate and consistent. That sounds really powerful. So for our listeners who might be wrestling with this problem right now, what are the biggest benefits they get from using Pydantic?
Well, first off, it saves you a ton of time and hassle. You don't need to spend ages crafting these super specific prompts to try to force the LLM to give you the output you want. And then you don't need to write a bunch of complex code to parse and validate that output either.
It's like cutting out a whole bunch of manual work, right?
Right.
Streamlining the process.
Exactly. You define what you want using Pydantic. We'll get into that in a bit, and Pydantic takes care of the rest. It instructs the LLM and makes sure the output matches what you need. So you end up with reliable data structures without having to become a prompt engineering master.
Okay, so you're saving time, you're reducing errors, and you're getting data you can actually trust. That's a big win. But let's rewind a bit. You mentioned this problem of messy AI output. Can you give us a real-world example of what that looks like and why it's such a pain?
Sure. Imagine you're trying to get an LLM to, let's say, extract contact information from a bunch of different websites.
Yeah, that sounds like a practical use case.
Totally. But without something like Pydantic, you might get the phone number first in one response, then the email, and then in another, the address is in a completely different order. Or maybe it misses a job title completely.
Oh, I see. So it's unpredictable, which makes it really hard to process that information automatically.
Exactly. You end up writing all this code to try and guess all the different ways the LLM might format its response. It gets really messy, really fast.
So it's fragile.
Yeah, exactly. It breaks easily.
Okay, so that's the headache. How does Pydantic fix it? What's its approach?
So Pydantic tackles it in 3 key steps. First, you define what kind of data you want. Let's say you want someone's name, their age as a number, and their city as text.
Okay, simple enough.
Right. Pydantic takes that and creates a clear, structured prompt for the LLM. It tells the LLM exactly what to return and in what format. No more ambiguity.
Oh, that's clever. So it's like giving the LLM a template to follow.
Exactly. The second step is that Pydantic doesn't just trust the LLM blindly. When the LLM gives its response, Pydantic checks it very carefully. Does it match the structure you defined? Are all the required pieces of information there? Is the data type correct? Like, is the age actually a number? It's doing all this validation behind the scenes.
Right. So it's like a strict teacher grading the LLM's homework.
Yeah.
Got to follow the rules.
Yep. Exactly. And the third step is that Pydantic can often retry automatically if the LLM's first attempt isn't perfect. So it might ask the LLM to try again, maybe rephrase something or fill in any missing pieces. This makes the process even more robust.
Oh, that's pretty neat. So you don't have to manually intervene every time there's a little hiccup. It tries to fix it itself.
Exactly. It makes things so much smoother.
Okay, so it sounds like we have a powerful system here for getting that structured data. Now, the tutorial dives into this thing called the agent class within Pydantic. Why is this agent so important? What's its role in all this?
So the agent class is your interface to all this power. It simplifies the whole process of interacting with LLMs to get structured data. You don't have to worry about the individual steps, like crafting the prompt, sending it to the LLM, validating the response. The agent handles all that behind the scenes.
It's like the conductor of the orchestra.
Yeah, a very efficient conductor. You just tell it which LLM you want to use, like a specific model from OpenAI, what kind of structured data you're expecting, which is defined by that Pydantic data structure, and the text you want to extract information from. The agent takes care of the rest.
So you're abstracting away a lot of complexity, making it much easier for someone to use this without having to be an expert in the inner workings.
Exactly. It's designed to be user-friendly. And for today's discussion, it's important to highlight that structured data extraction is a key use case for this agent class. That's where its power really shines.
Okay, so the agent is like the control panel, and we just need to input the right settings and press go. But before we get to play with this awesome tool, I'm guessing there's some initial setup involved, right? What do people need to get started?
You're right. There are a few things to set up, but the tutorial makes it fairly straightforward. It starts by mentioning Docker and Docker Compose. Now, these might sound a bit intimidating if you haven't used them before, but think of it like this.
Please simplify.
You're trying to run a specific program. Docker is like creating a self-contained box that has everything that program needs to run perfectly. The operating system, supporting software, everything. So no matter what kind of computer you're using, the program runs the same way.
Oh, so it's all about consistency and making sure things work smoothly, regardless of the user's specific setup.
Exactly. Docker Compose, on the other hand, helps you manage multiple of these boxes together. It helps us run the Pydantic demo application easily. The tutorial usually has links to the official Docker installation guides, so don't worry too much about the technical details right now.
Okay, so Docker and Docker Compose are like the foundation we need to build on. What else is on the list?
Next up is an OpenAI API key. Since we're using OpenAI's language models in this example, you need this special key to access their services. You can get one by signing up on their platform.
And I'm guessing the tutorial provides a link for that, right? Just to make it super convenient.
You bet. You can find it at https://platform.openai.com. Think of this key like a password that lets you use OpenAI's powerful AI. Keep it safe and don't share it publicly. And lastly, you'll need a text editor or an IDE that's an integrated development environment like VS Code or PyCharm. These are just tools that let you view and edit the code files for the demo.
Got it. So some basic software tools, an API key to access the AI, and a way to look at and edit the code. Makes sense. Now the tutorial jumps into the project structure, showing all the files and folders. Why is this organization important? What should our listeners know about it?
Good organization is crucial for any project, especially when things start to get more complex. It's like having a well-organized toolbox where you know exactly where everything is.
So it's all about clarity and maintainability.
Exactly. In this Pydantic demo project, you'll see a few key folders and files. Most of the action happens in the app folder. Inside, there's a file called init.py. This is a standard Python file that essentially tells Python to treat the app folder as a collection of code, like a package. Then you have main.py, which contains the core instructions for running the demo application. This is the part that allows you to actually interact with Pydantic.
Okay, so that's where the main logic lives.
Right. And then there's models.py. This is where you define those Pydantic data structures we talked about. They describe the type of information you want to extract.
Okay, so app is where all the core code hangs out. What about the other files in the main project folder?
Right, so you've got docker-compose.eml. This file is a set of instructions for Docker Compose. It tells Docker how to build and run the applications box, including things like what software to use and how to connect different parts.
Like a recipe for Docker.
Yeah, exactly. Then you have the Docker file itself. This one contains detailed step-by-step instructions for building that Docker image we talked about. Things like which operating system to use, what software to install like Python and Pydantic itself, and how to get your application code into that image.
Got it. So it's like the blueprint for creating that self-contained environment.
Precisely. Then there's requirements.txt. It's a simple list of all the Python libraries the application needs to work. So Pydantic would be on there, along with other supporting tools.
So it's like a shopping list for Python.
Exactly.
Yeah.
And finally, there's the .env file. This one is really important. It's where you store sensitive information, like your OpenAI API key.
Ah, yes, the secret ingredient.
Keeping it separate in this .env file is really important for security. You don't want to accidentally share your API key by putting it directly in your code.
Right. That makes perfect sense. Keep that key hidden. Now, let's talk about actually defining the data we want to extract. The tutorial spends a good amount of time on models.py and these things called Pydantic models. Why is this step so important?
Okay, so this is where you get to be the architect of your data.
I like it. We're designing the blueprints.
Yes. Models.py is where you define the structure of the information you want to get back from the AI. You're setting the rules, what kind of information, what format it should be in. Pydantic's base model class is the foundation here. You build your own data structures by inheriting from base model and defining the fields you want to see.
And each field can have additional information, right? The tutorial mentioned something called field. What does that do?
You got it. The field function in Pydantic lets you add details about each piece of data you want to extract. You can include things like default values, but the most important part for Pydantic is the description.
Why is the description so crucial?
Pydantic uses those descriptions to understand what each field represents. It helps Pydantic guide the LLM, telling it what to look for and extract.
Oh, I see. So it's not just about the data type. It's about giving context to the AI, making sure it understands the meaning behind the data. Can you give us a concrete example? The tutorial mentions a user details model. What might that look like in practice?
Okay, so let's say you want to extract someone's name in the user details model. You would define a field called name, and the type would be str, which stands for string. You would define it like name.str called field description, the full name of the user.
Okay, name.str. That makes sense. What about the deck in the description part?
The bootay means this field is required. The LLM must find and provide the user's full name and the description. That's you telling both Pydantic and Pydantic exactly what this field should contain. It's for clarity and validation. Now, let's say you also want to extract their age, but it's optional. Maybe not every piece of text will have it. You could define it like this. Age, optional int, field, none, description, the age of the user, if mentioned.
Okay, so optional int means it can be a whole number or it can be nothing if the age isn't found.
Right. And again, the description helps the AI understand what we're looking for. You could do the same for other fields like city and profession, making them optional text fields with clear descriptions.
So we're essentially building a template, telling the AI what kind of information we need, what it represents, and how it should be structured. The tutorial also mentions a product info model. Would that work in a similar way?
Exactly the same principle, just different data. You might have fields like product name, that'd be a required text field with a description like the name of the product. Then maybe price, which would be an optional number field, and currency, an optional text field for, well, the currency. The important thing is that each model acts like a contract between you and Pydantic. You're saying, this is the data structure I expect back.
No deviations.
Exactly.
Okay, so we've defined our models in models.py. We've got our data blueprints all set. How do we actually use them to get the information we need from the AI? This is where appmain.py enters the picture, right?
You got it.
Yeah.
Appmain.py has the main logic for this Streamlit web application. It's what lets you interact with Pydantic in a user-friendly way.
So it's the graphical interface, the front end, the part we see and click on.
Exactly. It starts by importing a bunch of useful tools, like Streamlit itself for creating that web interface, OS for handling things like loading your API key, logging to keep track of what's happening, and, crucially, it imports the agent class from Pydantic and those models we defined. User details and product info.
Okay, lots of moving parts coming together. Now, the tutorial points out this section where the OpenAI API key is loaded. Why is that handled so carefully?
Security, security, security. The code shows how to load the OpenAI API key securely from that .env file, remember?
Yes, the secret file.
Right. It uses the OS library for that. This way, you're not putting your API key directly in your main code where it could be accidentally shared. It's a best practice. Plus, the code even checks if the API key is loaded correctly, and it'll warn you in the Streamlit app if something's wrong.
That's a nice safety net. So, no accidental leaks.
Yeah.
Now, we get to the part where the agent itself is set up in the code. How does that work? What are we telling it to do?
Okay, so first, there's usually a variable that specifies which LLM model you want to use. For example, it might be set to GPT-4o Mini, which is a specific model from OpenAI. Then when you create an instance of the agent, you give it that model name and the result type.
Ah, the result type. That's where we link it back to our Pydantic models, right?
Exactly. The result type tells the agent which of your Pydantic models to use for extracting information. So if you want user details, you'd create an agent like this. Agent, LLM, model string, result type, user details.
So we're telling the agent which AI brain to use and what kind of data structure we're expecting back. Makes sense. Now let's bring in the Streamlit web interface. What does the user actually see when they open this demo app?
Okay, so the Streamlit interface is designed to be very straightforward. You'll see a big text box where you can paste or type the text you want to analyze. There's a drop-down menu to choose which Pydantic model to use, like user details or product info, matching the models we defined.
Okay, so we choose our data blueprint.
Right. And here's a really helpful feature. There's a section that shows you the JSON schema of the selected Pydantic model. The schema is like a technical blueprint written in JSON format, showing you exactly what the AI will try to extract. It's based on the names, types, and descriptions we defined in our models.
Oh, that's fantastic. So it's like a preview showing you what the output structure will look like. Transparency is key.
Absolutely. And finally, there's a big, tempting button that says Extract Information.
Okay, I'm ready to click it. What happens next?
When you hit that button, the code first checks if you've entered any text to analyze. If you have, it sets up the agent with the chosen LLM model and the Pydantic model you selected from the dropdown. Then the magic happens. Result, agent.runSync input text.
That line of code sounds powerful. What's happening there?
This is where the agent takes your input text, the description of the data you want from the Pydantic model, and sends a request to the LLM. It waits for the LLM to respond, and then it tries to map that response onto the structure you defined.
So it's doing the heavy lifting, the communication, the mapping, everything.
Exactly. It's the go-between, making sure everyone speaks the same language.
And what does the user see once the agent has finished its work? What's the output?
If everything works out, the Streamlit app will show you a success message. Then you'll see the extracted data displayed in two ways. First, as a nicely formatted JSON string, which is a common way to represent structured data, and second, as the actual Python object. It also might show you how much of the LLM's resources were used, like the number of tokens it processed, just for reference.
So we get the data in a format that's easy for computers to understand, and we get to peek behind the curtain and see a bit of how much effort the AI put in.
Exactly. But what if the LLM doesn't give a perfect response? What if it doesn't quite fit the Pydantic model?
Good question. Things don't always go perfectly in the real world. How does the code handle those situations?
That's where error handling comes in. The code uses a try.except block to manage these potential issues. It specifically looks for a type of error called validation error, which is what Pydantic throws if the output doesn't follow the rules you set. If that happens, you'll see an error message in the app, and it'll often show you the specific validation errors, which can help you figure out what went wrong. There's also a general error catch for any other unexpected problems.
Okay, so it's like having a safety net to catch those errors and provide helpful information about what went wrong.
Exactly. It's all about making it easier to debug and fix issues.
So just to recap, we've got those models that define our data structure,
Yeah.
main.py using the agent to handle communication and validation, and the Streamlit interface for user interaction. But we also have those other supporting files, requirements.txt, Dockerfile, docker-compose.eml, and .env. What do they do in this whole setup?
These files are all about making the application easy to set up and run consistently, no matter who's using it. Remember requirements.txt. That's our list of Python libraries the application needs. It includes things like Pydantic and Streamlit, the Docker file, that's the set of instructions for creating that Docker image, the snapshot of the perfect environment for the app to run in. It includes the operating system, Python, all the necessary libraries, and your application code.
So it's like a recipe for building the application's environment.
Exactly. And then docker-compose.eml, that's what defines how to manage applications that use multiple Docker containers. In our case, it tells Docker to use the Docker file to build the image, how to run a container from that image, and how to load those environment variables from .env, including that all-important secret API key.
And the .env file, that's just where we keep our sensitive information, right? Separated from the main code?
Exactly. It keeps everything organized and secure.
Okay, so for someone who wants to try this out, what would be the general steps? How do they get this demo up and running?
It's pretty straightforward, thanks to Docker Compose. First, they would open their terminal or command prompt and navigate to that main Pydantic iDemo folder. Then they would type in Docker Compose upbuild. That command tells Docker Compose to look at the Docker file and build the image, installing Python, all the libraries, and putting your application code into the image. Once it's built, Docker Compose will start a container based on that image. It'll also load the API key from .env into that container. Streamlit, as configured in the Docker file, will then start up a web server inside the container. Then the user can open their web browser and go to http://localhost.8501, and that will open the Streamlit app ready to play with.
That sounds pretty painless, all things considered.
It is. Docker really simplifies things.
Okay, as we wrap things up, what's the key takeaway for our listeners? What should they remember about Pydantic and the agent class?
The main point is that Pydantic, especially when using that agent class, offers a powerful and easy-to-use way to get structured, validated data from LLMs. It takes away a lot of the headache of prompt engineering and manual parsing, saving you time and reducing errors.
So we're not just getting raw text from the AI, we're getting usable information in a format we can actually work with.
Exactly. It's about turning AI's potential into something practical.
And what kind of real-world applications can you see this being used for?
Oh, tons. Imagine automatically extracting information from customer feedback forms, pulling structured data from research papers, or organizing information from loads of documents, all in a consistent, reliable format.
That sounds incredibly useful for all sorts of workflows and applications.
And if any of our listeners are thinking about using Pydantic for their projects, or if they want personalized help with AI and data extraction, they can reach out to the experts at https://www.sogenie.com. They offer one-on-one training and consultancy to get you up and running.
That's a fantastic resource. Now, for a final thought to leave our listeners with, let's consider this. How does defining the structure of the information we need before interacting with AI change the way we use it? What other areas could benefit from this structured approach? Instead of just asking questions and hoping for the best, what if we started by clearly defining the shape of the answers we need?
That's a great point.
It's a different way of thinking about interacting with AI, and it could unlock a whole new level of efficiency and accuracy in how we extract and use knowledge. It's really about being intentional and precise in our interaction with these powerful language models.
I think that's a perfect note to end on.